Let's start today's video. In today's video we will discuss the quality of service and firewall. So today's video will be very short. Stay with us. The quality of service is a set of techniques and policies that ensures critical applications and service receives the necessary bandwidth and minimal delay for proper functioning, especially in network handling multiple types of traffic with varying performance requirements. So the key quality of service metrics are the keys are bandwidth, latency, feeder, and packet loss. Bandwidth. Bandwidth ensures bandwidth ensures the sufficient bandwidth is allocated to important applications. Latency, the delay between sending and receiving data QoS ensures minimal delay for real-time applications like video conferencing. Variation in packet arrival time important for real-time traffic. And packet loss, ensuring minimal packet loss for services that require high reliability. Then we have QoS techniques, traffic prioritizing, bandwidth reservation, and traffic stepping. Traffic prioritizing. Certain types of data, e.g., voice or video, are given priority over less critical data, that is bulk file transfer. Then we have bandwidth reservation, allocating a guaranteed amount of bandwidth to specific application. Then we have traffic stepping, regulating the flow of data to prevent congestion by smoothing out traffic peaks. Then let's see the summary. The transport layer ensures reliable. The summary about the transport layer. The transport layer ensures reliable communication between applications. The UDP provides fast, connectionless communication, while TCP offers reliable, connection-oriented data transmission. Third one, congestion control algorithm like the leaky bucket and token bucket manages traffic flow to prevent network congestion. Quality of service QoA techniques guarantee performance for critical applications ensuring bandwidth, low latency, and minimal packet loss. So this is all about the transport layer. This is a summary, some points to be noted in a nutshell. Next, let's jump into the one remaining topic from this chapter. We have firewall. And before firewall, we have digital signals, a public key. So in the digital signals, there's a two key. This is private key and public key. So the thing is, when any message is encrypted from this is a sender and this is the receivers. Suppose DS generation algorithm, digital signal generation algorithm, and this is generation algorithm, and this is digital signal verification algorithm that verify the message that is sent by the sender. So it basically verifies that the message is valid or not. The message that is sent by the sender generation algorithm, message generation algorithm. This is the message, and after generating the message sends to the receiver to the verification algorithm so that it can verify the message that if it's valid or not. So to get the message, the sender will use his public key, and to send to the receiver, the receiver will use public key in order to get the message of the sender. And in the same way, the sender will use the private key of the receiver in order to send the private message only that will be sent only to the receiver. So this is the whole fact. And one thing that is important, that if any message is encrypted from the sender side using private key, it can only be decrypted using the public key at the receiver side. That's just the same thing that I said. So now let's see the firewall. So this is the external network and this is the internal network, and the firewall uh, stays between them. A firewall is a computer network security system that restricts internet traffic into, out of, or within a private network. So let's see the types of firewall. There are packet filtering firewalls and application gateway or proxy servers. So let's see packet filtering. Under the packet filtering we have some set of rules. SADA port number protocols. If rules are masked, then forward or discard. So basically this is a kind of pseudocode and or algorithm. Sorry, this is kind of pseudocode. Default actions and data protocol. So this is PEF, packet filtering firewall. Internet and private network between them. The packets are situated. Then we have application gateway or proxy server. Under the application gateway proxy server, we have more. This is more secure than the packet filtering firewall. It's processing overhead, check data payload, and this is the internet host. This is a proxy server. This is the internet. This is all about the application gateway proxy server. So thank you for watching this video. Today's video is ended, and see you in the next video where we will, as promised, we will discuss the Dijkstra's algorithm and the Bellman port algorithm. So stay tuned. Thank you.